Good day. I am Cherelle M. Esteban. Before I will going to start the discussion, please allow me to share with you the four objectives for this discussion. As you can see in the slide, these are the objectives for this discussion. So after completion of this chapter, the reader should be able to first, evaluate and propose solutions for first directional, specimen, and requisition procurements problems in relationship to the customer interface needs of a laboratory. Second, describe the workflow and spatial design factors that must be incorporated into the physical layout plan of the laboratory. Third, use the tools of workflow and design in preparing a functional narrative document for a laboratory building or remodeling project. And the last objective for this discussion is work with architectural, engineering, and construction firms in overseeing the completion of a building or remodeling a project. So let's proceed to the chapter highlights. First, we have the interface with customers, patients, and other users. Second, internal work processes of the laboratory. Third, organizing and budgeting a project. And last, we have the project design and construction. Workflow and laboratory design is a significant fulfillment of the planning and organizing management functions. Where the laboratory is located, how it receives and processes its specimen, the spatial relationship of each section, and the physical layout and arrangement of work areas and instruments are all factors that directly affect the operations of a laboratory. So, effective laboratory design goes beyond providing a safe environment. It ensures lab users are hazard free and in a healthy environment, all while getting their work done. Also, effective workflow management can streamline workflows and has been shown to reduce the potential for medical errors and improve the quality of care provided to patients. So, this topic is closely aligned to the subjects of workflow, work processes, and the analysis of work itself. This discussion addresses the physical or structural relationships of work and the workplace and falls into the branch of management called industrial engineering, which deals with job analysis. So, to have understand to have a deeper understanding with this discussion, kindly listen to the next reporter. Thank you.
Good day, everyone. I am Jasmine Valencia, and today I will be continuing the discussion about the management of laboratory operations, workflow, and laboratory design. First, let's talk about the interface with customers, patients, and other users. The laboratory must interact in two directions with patients, clients, and other users of its services. First, the intake or requisition of specimens and requests for services. And second, the return of information and result. The resolution of these directional problems usually determines the geographical surface base of a laboratory. The second of these directions, or the return of information and results, has for all practical purposes been resolved. What this means is that with worldwide instant telecommunications, computer linkage, and fax machines, the physical proximity of the laboratory is of no relevance. Next, first directional or specimen procurement problems. The laboratory is a relatively unusual entity in healthcare, so it does not need direct contact with the patients, and specimens can be collected and transported to the lab either by laboratory personnel or by intermediaries. So this feature has made the laboratory the center of efforts to consolidate the healthcare services. And up to this point, the time involved in delivering the specimen to the testing site has made in-house laboratories the most viable option for inpatient testing. However, this is changing because of improvements in delivery systems and collection instruments. First is technological advances will bring about changes in both satellite and centralized laboratories. Ease of use and modularity make it possible to perform tests at the patient's bedside and in near care such as operating and emergency rooms, intensive care units, and physicians' offices. And then again, the improved cost-benefit economics of procedures and profiling instruments continue to support the centralized centers. Next, drawing station placed at a strategic locations in the hospitals like outpatient departments, oncology, and admissions, and in satellite facilities like physicians' offices, shopping centers, and walk-in clinics, permit the laboratory to control the collection and delivery of specimen. And lastly, overnight or same-day delivery services will eliminate the need for physical proximity of the laboratory. And as a result, the local laboratory is feeling increased competitive pressures from regional and national laboratories seeking to attract additional clients. And lastly, the case for centralized laboratories. Although the benefits of near-care testing are tremendous, especially in imaging space and logistical problems, it does not offer a panacea. So accessibility and cost of care concerns will continue to have a major impact on the delivery of healthcare services. And for this reason, the manager must carefully weigh the advantages and disadvantages in each service option. The centralized laboratory with enhanced specimen intake strategies will remain a viable delivery mechanism. So once immediate stat and triage concerns are satisfied, specimen procurement becomes mainly a transportation problem. The case for a centralized laboratory is strong. Economies of scale are possible in a centralized laboratory, which can handle a large volume of tests and afford the highly efficient, tough, costly, and profiling instruments and the well-trained staff necessary to run such equipment. So, manager must pay attention to the marketing of laboratory services like convenience, public visibility, ability to attract clients, as well as the timely receipts and delivery of specimens at the testing site. So that's all for my discussion, and thank you for listening.
Good day everyone, I am Babyless Angel Galis Makagubang. So in line with the discussion of the workflow and laboratory design, I'll be going to discuss one of the subtopics of the main discussion, and that is internal work processes of the laboratory. The laboratory as a part of the healthcare community will continue to undergo an explosion of change. A whole array of workflow and design factors must be incorporated into the physical layout of the laboratory, including the planning for known and anticipated needs as well as the possible use for an entirely different purpose in the future. Laboratory areas may need to be adopted during the life of the building to totally unrelated functions because of changes in technology or service needs. Internal work processes of the laboratory reinforces the value and justification of the building or remodeling the project. So under this, the literature of workflow and laboratory design centers around two closely related concepts, and that is flexibility and modulation. So when we say flexibility, it is a design or physical layout that allows a laboratory to readily adapt to changing space needs, while the modulation is the structural components that enables a laboratory to achieve flexibility. So these two principles should be in part in each stage of the design and planning process, including decision about floor space and room size, cabinetry, electricity, plumbing, ventilations, and even the movability of the walls. Sink, drains, pipes, and other plumbing fixtures used to make it difficult to rearrange an area. But with the advent of new grid installations techniques similar to electrical ceiling matrices, perhaps plumbing design can add to the adaptability of a space. So let's proceed to the functional and spatial design. The goal of planning the physical and structural aspects of workflow in laboratory design is optimal productivity. Functional and spatial design, the space should enhance the work being performed and adapt to the needs of the people rather than being an impediment that must be adapted to. So with this goal in mind, workflow in laboratory design deals with the spatial relationship between people, equipment, supplies, and the traffic generated by laboratory activities. For optimum functioning, laboratory design must take into the account the following factors. The first factor is the space allocation for the task to be performed with sufficient room for personnel, equipment, supplies, patients, and the traffic generated by the activities involved. Second, ergonomic planning of cabinetry and workstations for enhanced productivity. Third, placement of utilities, plumbing, ventilation, lighting, electrical outlets for computers and other equipments. Fourth, traffic flow of personnel, equipment, and patients. Then, sufficiency and convenience of storage areas. 6. Safety equipment and design including ventilation, showers, egress, containment and disposal of hazardous waste, and a changing area for removal of contaminated clothing and protective equipment. And the last one is the staff facilities such as lavatories, locker rooms, and eating areas. So with these 7 factors must be considered in light of guidelines and regulations of accreditations and licensure agencies. Why? Because for this reason, having a well-defined laboratory goes beyond simply providing a safe environment that guarantees the lab users a risk-free and in healthy environment while still allowing them to complete their work. So that would be the end my discussions, and let's proceed to the next reporter.
So good day everyone, I am Madabia P. Akmali. Now let's move to the organizing and budgeting project. When you say organizing and budgeting, it's involved how you follow or arrange the plan. Let's talk about workflow and laboratory design, which involve the 4 stages organization, which includes the management planning process, meaning it is how a process or assessing an organization goes. Much like writing a business plan, it must have a step to be followed. Next one is the written narrative description. It is something describing the situation or narrate from the word narrative. It's narrate the budgeting project. It's writing down everything associated in the plan. Next one is the budgeting. Of course, it is important after you make a plan, you must think the budget that you can use in the project. Budgeting is simply balancing your expenses. By budgeting, help create capital stability. Last one is the graphical display. Make a flow chart or a timeline of your project schedule so that you can organize the project in a details and correct. These 4 stages can be further divided into 2 phases. First, the internal aspect of planning and budgeting for a project, and process of working with architectural, engineering, and construction firm to bring the project to fruition. Although part of these phases are going on simultaneously, the laboratory should have a good idea of its needed preferences and financial resources before approaching outside agencies. Now let's move to the project design team. A project design team should include both laboratories and construction specialists. The term should solicit input from pathologists, technical and administrative managers, clinical scientists, supervisors, and especially the bench level staff who will work in the area, because they are the one execute the task properly. It is also important to obtain suggestion and advice from those who will be actively interfacing with the users, namely phlebotomists, clerical staffs, and supply stock personnel. Once the design team is in place and information has been gathered and prepared, it is time to meet the architect and engineers who will be working on the projects. Now let's move to the project budgeting. It's talk about preparation of the capital budget and contains specific tools and techniques for justifying and preparing a budget for expensive and long-term projects such as building or remodeling a laboratory. Of course, in a project budgeting, we must plan, prepare all the money that we're gonna use. We must list all the important tools that needed and how we budget our capital. We must think this capital budget how we divide it well. A manager may be somewhat intimidated by the language and techniques used to put the plans on paper and deal with the formal documents on the building profession. That will be all. Thank you.
Good day, everyone. I am Jenna Ives El Moramento, and I will be discussing the project design and construction. Like all professions, the building trade has a wide variety of documents and visual aids that can be used for planning, contracting, and constructing a project. Computer simulation programs have reached a point in which real-life pictures and scale models can easily be produced to demonstrate how different options and decisions affect the final structure. From conception to production of the final construction models and contracts, several steps or phases are common to most project plans. Much of this work may be overseen in cooperation with the engineering department or hospital-based laboratories. In a large multi-hospital system, the corporation may have a separate architectural and construction division assume responsibility for the project. In this case, the manager should be familiar with the functional narrative document, or also known as the FND, graphical depictions, and the contract documents produced in cooperation with the architect. So, as shown in the screen, this is the development and review process. These are some of the works that must be processed, in which it is divided by phases, up until we reach to the point where construction must already be done. So the functional narrative document. The functional narrative document, or the FND, describes the purpose, functions, relationships, and activities of their under construction. It is prepared by the project design team. So the functional narrative document, or also known as the FND, describes the purpose, functions, relationships, and activities of their under construction. The functional narrative document, or the FND, describes the purpose, functions, relationships, and activities of the area under consideration. It is prepared by the design team for the engineers so that they can prepare formal plans and construction agreements. In creating the functional narrative document, it is mostly the crucial planning stage. This is because there is a possibility that there is a temptation to skip or shortchange due to the excitement of drawing floor plans and getting on with describing the new desirable features. However, careful planning at this point avoids mistakes and costly corrections later in the process. This phase is also strikingly similar to the process of planning and designing a laboratory information system, or the LIS. Many of the steps, techniques, and process analysis methods are the same. In each process, attention to detail at the earliest planning stage is a key factor in the success of the project. So what does an FND contains? So the content of the functional narrative document are organized by the discipline. So specific detailed information must be provided in the functional narrative document about space, spatial relationships, utilities, lighting, ventilation, and so on. These factors can be organized by discipline, hematology, chemistry, or function, clerical, specimen processing, supply storage, and many more. But each component must be addressed. So the type of tasks and movements, especially in terms of space and coordinated efforts, should also be considered. So the FND contains the volume of activities, including the amount of traffic generated by the number of tests performed, supply restocking, specimen processing, telephone, and other communication transactions, and the movement of people. Next is the nature and structural needs. This involves the power, utilities, counter space, protective equipment, and so on. Next is the kinds of instruments and equipment that will be present in their space specification. Next is the communication links, both inside and outside the laboratory, including telephone, intercom, fax machines, and all part of the LIS. And the number of personnel and the staffing patterns, the supply requirements in consideration of requisitioning, storage, and dispensing, and lastly, the detailed description of the plans for the computer system or the LIS, including the wiring and many more. So the FND preparation. Information about most of the items in the FND is readily available in the laboratory or easily obtained from an architect. Sources for the information are historical workload data, charts showing minimum square footage allocation and structural requirements for people and equipment, manufacturer installation specification manuals, and code enforcement regulations. However, spatial relationships must be evaluated for each situation. Spatial relationships are the distance and physical structures between two or more areas that must closely interact for the work to be completed. This is because spatial relationships may hinder or expedite the flow of specimens within the laboratory, especially for those samples that must travel down two halls or pass through several other sections before being delivered. According to Koenig, 1985, he offers several ways to incorporate spatial relationships into the functional narrative document, including the bubble drawings, block and schematic drawings, department relationship matrix, and the building models. So the bubble drawings are a series of circles or bubbles that represent a function or area and depict the flow of information and tasks using lines and arrows to show the direction and connections in the relationships. So as shown on the screen, this is an example of a bubble drawing. Next is the block and schematic drawings. These are preliminary floor plans or sketches representing the first efforts of the architect to put the functional narrative document on paper. So the block and schematic drawing is simply the floor plan. So as you can see, this is an example of the floor plan. Next is the department relationship matrix. It shows the areas that interact and also quantifies the degree of coordination involved in the interaction. This is an example of the department relationship matrix. And lastly, the building models. The building models may be lifelike, built-to-scale replicas, or color-coded blocks that represent people, counters, furniture, and instruments. Components can be moved around on a floor graph to display a variety of configurations and design options. So in other words, or in simpler explanation, the building models is simply the miniature models. The functional narrative document is an extensive, detailed package covering all aspects of the workflow and project design. It is intended it is intended to give the architects a comprehensive overview of the purposes, functions, and needs of the user and provide the information needed to prepare the initial schematic design drawings of the facility. These drawings also go through several revisions before being given to the construction company. So therefore, for example, the floor plan is still subjected to change. So that's it for my discussion about the project design and construction. Thank you and have a good day.
Good day. Again, I am Cherelle M. Esteban. And this part of the discussion, I will going to talk about the architectural and engineering documents, graphical depiction documents, and the working drawings and project manuals. So, let's begin with architectural and engineering documents. Upon receipt of the functional narrative document, the architects and engineers assume direct responsibility for preparation of the formal construction plans. The laboratory and frequently regulatory agencies are asked to review, approve, and sign off on each phase of the design processes as it progresses through the graphical depiction documents to the final approval and insurance of a project manual. The next is the graphical depiction documents. So in this section, we have the three edition or phases before completion. First is the initial schematic drawings of the facility developed from the functional narrative document. Second, the design development drawings from which building codes and material specifications can be prepared. And the final working drawings or blueprints that will be used for the construction. So we will discuss the three edition or phases one by one. So, first is the schematic drawings. Although the functional narrative document frequently contains sketches of floor plans, schematic drawings are the first attempts of the architects to interpret the information in the F&D. Schematic designs drawing are usually straightforward, single-line drawings that outline the various areas of the project. They are drawn to scale with the preliminary estimates of square footage allotments and key elements such as instruments, sinks, and workstations outlined. These drawings are used by the laboratory and architect to review how project is shaping up, correct any misunderstandings, and correct any problems that have been identified. So, the design development drawings is followed after the schematic drawings. So, when agreement has been reached on the schematic drawings, the architect can proceed to the developing the design development drawings. So, in this stage, construction details are added, including specific space layout patterns, structural features and requirements, utilities and plumbing placement, ventilation and airflow plans, and building codes and regulations compliance. So, this phase may include uh, a full-scale model of the project as well as line drawings. So from this point on, it becomes increasingly costly to make changes because of the professional time and research already invested in the project. So again, this point is increasingly costly to make changes because of the professional time and research already invested in the project. So so it is very important that before we will going to reach the design development drawing, so it, you have to make sure that everything is working well. Kasi if nandito na kayo sa design development drawing, then there are changes. So it becomes increasingly costly na talaga. So for this reason, it is crucial that all aspects of the projects be extensively reviewed and double checked for agreement by both the laboratory and architect before the final working drawings are prepared. So after that, since we already know what is design development drawings, so let's proceed the working drawings and project manual. So once final agreement has been obtained from all parties, the architects complete the working drawings or blueprints that are used for construction of the project. The design process culminates in a project manual or construction guidelines proposal, which contains the working drawings and detailed information on the types of building materials and construction techniques to be used, informally called the speak book. So, in the speak book, it includes a specific itemized information and instruction about everything. So, construction schedule targets like types of writing, light fixtures, carpet, and cabinetry and furniture include ceiling highlights, wallpaper patterns, decorative details, doorknobs, cement reinforcements such as plumbing or everything down to and including the kitchen sink. So from these final documents, the construction project can be completed. And because of the meticulous planning that has been taking place, the laboratory workers will be able to enjoy their new facilities and achieve their goal for a better patient care. So that's the end of this discussion titled Workflow and Laboratory Design. I know that the other reporters already give their best for you to have an understanding about the topics, but we will still have a recap for you not to easily forget the discussion. So first, again, the interface with customers, patients, and other users. The intake or requisition of specimens are requests in this section for services and the return of information results. And the first directional specimen procurement problem. So in this section, the assigned reporter already talked about that it does not need a direct contact with the patients because specimens can be collected and transported to the lab either by laboratory personnel or the intermediaries. The case for centralized laboratories, the accessibility and costs of care concerns will continue to have a major impact on the delivery of a healthcare services. And again, the internal work processes of the laboratory. So in this part, the laboratory as part of the healthcare community will continue to undergo an explosion of change. The flexibility and mutilation in these sections, it talks about the flexibility and mutilations. While flexibility in design and physical layout allows the laboratory to readily adapt to the changing needs. Mutilations in the structural components enables the laboratory to achieve flexibility. And next is the functional and spatial design. So in this part, it's already discussed to you that the goal of planning the physical and structural aspects of workflow and laboratory design is optimal productivity, the organizing and budgeting a project. So in this, they talk about the organizations, which includes the management, planning, process, written narrative descriptions, budgeting, and graphical displays. So these four stages can be further divided in two phases again. So the two phases are the internal aspects of planning and budgeting for a project and the process of working with architectural, engineering, and construction firms to bring the project to fruition. And the project design team. So they told you about that project design team should include both laboratorians and construction specialists and the project budgeting. So in this project budgeting, the reporter told you that preparations of the capital budget and contain specific tools and techniques for justifying and preparing a budget for expensive and long-term projects such as building or remodeling a laboratory. So the project design and construction. So I know that the reporter already explained to you that in this part, the building trade has a wide variety of documents and visual aids that can be used for planning, constructing a project. And my topic, the architectural and engineering documents, as you can remember, I told you that the architects and engineers assume direct responsibility for preparation of the formal construction plans. And again, the graphical depiction documents. So in this part, I already told you the three editions or phases before completion because if magkamali kayo in the middle part, there will be an increasing click cost. So it's very crucial to know the graphical depiction documents. And again, the working drawings and project manuals. I already told you about the speak book where it includes specific, itemized information and instruction about everything. So before I will going to end the discussion, let us all be reminded that planning and organizing management duties are significantly fulfilled in part by the design of workflows and laboratories. The physical structure and organization of work areas and instruments, as well as the location of the laboratory and how samples are received and processed, all have an immediate impact on how well a laboratory runs. Therefore, effective laboratory design extends beyond offering a secure setting. It guarantees that lab users are risk-free and in a healthy environment while they complete their tasks. Additionally, efficient workflow management can speed up process and has been demonstrated to lower the risk of medical errors and of course enhance the standard of a care given to patients. So that's all for this discussion for in this recorded videos. I hope you guys learned something. Thank you for watching.